Good morning, everyone. I think we're going to get started now. Thank you all for joining. Um, Let me advance the slide to the February meeting of the MCAN Better Building Advocate Zoom happening today, 9 a.m., Thursday, February 19th, 2026. And my name is Jack Lundgren. I direct the Embodied Carbon Initiatives here at MCAN. And fortunately, in Massachusetts, we're seeing a whole lot of momentum around this issue. We had the state release their recommendations report last month. And so I'm super excited to welcome our presenters here today, Chris Magwood from RMI, Mélanie Trottier from Builders for Climate Action, to give their insights from a recent embodied carbon study that is specific to Massachusetts and Massachusetts new residential construction. But before we get started, just want to go through a few logistics with you all. Um, Please rename yourself if you can. You can click on the three dots in the corner of your image, or you can alternatively put them into the chat. Any preferred pronouns, the town or city that you're from, and any organization that you might be representing. The Massachusetts Climate Action Network seeks to accelerate equitable decarbonization in Massachusetts by empowering local residents, advocates, and community members to take action. We were founded in 2000. We provide a network and expertise to help local groups take action on the climate. MCAN is a network of organizations, over 60 chapters around the state of local climate groups, and thousands of amazing advocates like yourself. MCAN hosts monthly, sometimes twice monthly programming. On the screen here, you can see our recent meetings, our recent webinars, and these can be accessed on our website. Our recordings are published there, so I encourage you to go check those out. The session today will be recorded. If you have questions, please hold until after the initial presentation. Please hold your chats as well until after the presentation as well. And at that time, after the presentation, you'll be able to raise your digital hand under reactions to be recognized. Please mute when not speaking. Keep your comments brief, and just know that we may not be able to address all questions and comments during this hour-long meeting. So again, please rename yourself if you can, using your preferred pronouns, the town or city that you're from, and any relevant organizations that you'd like to highlight. So thank you all for joining. Feel free to follow us on social media. And I just want to quickly extend a special thank you to the Jampart Charitable Trust, whose support has made this program possible. And with that, I want to return to the meeting topic of today, which is our presentation about the Massachusetts 100 Home Embodied Carbon Study, joined with Mélanie Trottier and Chris Magwood. So happy to have you both here to talk about the results of the study and the insights. I'll turn it over to you both. Thank you so much.
Thank you, Jack.
Yeah, thanks, Jack, and the whole MCAN team for inviting us to do this. Okay, well, as Jack alluded, we're here to talk to you about some insights from the 100 Home Embodied Carbon study that was released right at the end of last year. It's a really exciting report. It's really the first of its kind to look at a really wide array of homes. And to be looking both at the not only the embodied carbon side, but also the operational carbon side. There are lots of people to thank. We'll mention a few of them here, but we're going to sort of go through what are the highlights of this study. At the end, there's a QR code to go access the study. I would encourage you to do that. There is so much data in there. We're really kind of skimming off the real top level highlights, but if you are interested in the topic, it's a really rich report, and we encourage you to go and check out the whole document. Okay, well, I will just give a brief introduction to myself. I am a manager at Rocky Mountain Institute, known as RMI, in our carbon-free buildings team. I come from a long background in residential design and construction. I also ran a residential design construction school for a number of years. And I call myself an accidental embodied carbon nerd. I didn't set out to make this topic the thing that I do full time. But for our own practice back in 2011, I decided it would be good to be able to understand the carbon emissions with the materials associated with the materials that we were building with. And I thought that I would do this in like an afternoon off the side of my desk one day. And almost 15 years later, it's still the thing that I do. It's a really interesting topic, and it was really just getting going back in sort of 2010, 2011. There was very little data, and it's been incredible to watch the progress on this topic in a relatively short time. And I think this study really highlights what having access to that data and all the work people have put in to make that accessible really means. And I'll turn it over to you, Melanie, for your intro.
Yeah, Mélanie Trottier. I'm a embodied carbon analyst and researcher with Builders for Climate Action for now 5 years. Um, Also a bit coming the same as Chris, like I was doing my Passive House certification and then wondering like, yeah, this is not the whole piece. Energy efficiency is great, but like we're missing a point there. So just started with Builders for Climate Action and done a lot of research, helped develop the tool. And yeah, so excited to have you today and present this study. That was one of the big one we've done and really excited about it.
Okay, so for those of you who are new to the topic, I'm going to spend just a couple minutes talking about what we mean when we say embodied carbon and why it's even important to be looking at this topic. So we'll go to the next slide. So the the realm of embodied carbon fits into the entire life cycle of, you can look at the life cycle of a single product or you can look at the life cycle of a whole building. But through either lens, there's a whole array of places where emissions happen when we get into making a building. You can see they're sort of laid out here. There's this alphanumerical hierarchy that life cycle assessment sets out. Emissions sort of going from the A1 module all the way to the C4 module, and including everything that happens along the life cycle where emissions could be generated. So without going into too much detail on this, really when we've been focusing in the buildings realm on energy efficiency and operational emissions, we're really looking at this sort of like B6 phase that's here in gray. When we talk about embodied carbon, we're essentially talking about everything else that happens along the way. This study in particular, we'll get into this in a bit more detail, is focused on the product stage here, the A1 to A3, the emissions that happen when you actually make a building product. So we'll go to the next one. We figured this out using documents called EPDs, or Environmental Product Declarations. That's the little document there where it says GWP emission factor. Those are an ISO standardized way of conducting a life cycle assessment of a building product. And you get a GWP factor. GWP stands for global warming potential. It's the unit is kilograms of carbon dioxide equivalent. And so for every product that has an EPD, you know how much emissions is associated with a certain amount of that product. So to do a study like this, we have to figure out the material quantity of every product that we're going to look at, multiply it by that emissions factor for the product. Then you get the emissions associated with the product. And then you do that for all the products, sum them all together, and you get total emissions for the building. So when we start talking about the totals that we see from this study, this is kind of the math that's behind all of that. And then why should we care about this topic? We should care because the emissions from making building products in this case, just for new homes and just in the United States, is really big. So, based on studies previous to this one, we've sort of estimated that there is about 63 pounds of carbon dioxide equivalent per square foot of new home construction. Typically, over the last bunch of years, about 1.8 billion square feet of low-rise residential new homes have been built in the US, and that means somewhere around 53 million metric tons of emissions are associated with making the building materials for new home construction in the US. And to put that in context, that little box on the bottom right shows you that that's somewhere in the range of the emissions from entire countries like, Austria, Greece, Hungary, and Norway. So just the residential building products industry, just for the US and just for low-rise residential construction, has the same impact on the climate as entire countries. And so that's why we care about this, and that's why we think that the insights from this study are so important.
Also, because those emissions are released at the beginning of a project, and they're the one that we need to reduce our emission within a meaningful time frame within the next decade. So we cannot ignore those emissions and only look at energy efficiency.
Okay, so I'm going to give you just a quick intro to the 100 home study itself. That'll be this next little section. And I'll just kick this off by saying, we're really, excited that this project happened in Massachusetts, and it owes a huge debt to the team at NEHRS, the Northeast Home Energy Rating System Alliance, who not only were the sort of driving force behind this study, but they were also the driving force in linking me and my work at RMI with the ResNet organization. And together with ResNet, we have created a standard for measuring embodied carbon in new homes. It's exciting. It's about to be published sometime in the next couple months. But this study sort of was able to use the draft version of this ResNet 1550 standard to sort of underpin the methodology of the study. So it's not only a unique study on its own, but it's a really great sort of first use case for this new standard that's going to be coming in early 2026. And I'll hand it over to Mélanie to sort of talk more about the study.
Yeah, there were three big funders of that study that grant the Northeast Home Energy Rating System Alliance, the NEHRS, to integrate HERS rating software for new homes with the building emission accounting material like the BEAM tool that Builders for Climate Action developed. So the grant-supported partnership between NEHRS, Stephens and Company, Ekotrope, Builders for Climate Action, and NMR Group to train participating HERS raters and document the upfront embodied carbon emission for 100 homes, 100 new Massachusetts homes. So there were like 13 raters that took part of that study, which is unique for this kind of study so far. So the goal was really to explore the feasibility of adding embodied carbon analysis to typical operational energy assessment conducted by HERS Rater. They're already doing the energy modeling for those homes. So how can we leverage their workflow to add embodied carbon? And then use those assessments to establish a baseline value for embodied carbon emission for new homes in Massachusetts. There's why we looked at HERS raters and their workflow, because there's a lot of overlap between energy model and embodied carbon model for residential. So that's why embodied carbon assessment into the HERS rater workflow was really a primary goal. There's some overlap between information needed for an energy model. When we look at energy model, we mostly look at the thermal envelope assembly in terms of material. And then for an embodied carbon model, we also look at that thermal envelope assembly, but also the rest of the building. So the whole building, the structure enclosure and partition. So there was a lot of information that were already collected by the HERS rater. And then the idea was to understand what is the missing information that we need to measure embodied carbon without adding too much work to the raters. So part of that study was to map what can we extract from Ekotrope to then like add into Beam to do the embodied carbon model. We saw the life cycle stage earlier. So in this study, we looked at A1 to A3 for the embodied carbon. And since we're using homes that already have energy modeling, we were also able to look at the operational carbon emission. And we looked at it over 25 years. So operational carbon emission, they happen every year, right? It's a factor of like how much energy you use and which kind of energy you use. So we looked at it for 25 years. And what was included in the embodied carbon assessment was most of the buildings, so footing and slab, foundation wall, exterior wall, party wall, exterior cladding, windows, ceiling, roof, structural element, interior wall, and garage. And the uniqueness of this study was the first time we looked at mechanical, electrical, and plumbing systems, so MEP system. And that is because all the work that they did with the 1550 standard that provided baseline to do this work. And what we realized is there's already a lot of information that we were able to extract from the energy model. Some of it was like we could extract partial information, and some are just like not part of any energy modeling because it's not part of the thermal envelope, right? So the basic workflow of that study, we had those 13 raters selecting 100 registered projects. So they had Ekotrope energy model, where we had the thermal envelope material and also the MEP information, and then the drying set or SketchUp. And then we developed a beta integration worksheet. Since we're working with two legacy tools, the Ekotrope and the Beam, they were not talking to each other directly. So we had to develop a intermediate tool to be able to transfer data to the other one. And in that beta integration sheet, we were able to import the material information from Ekotrope, so dimension and type of material. But since it's not all in this energy model, we also needed the rater to go back in the drawings and then have some manual input for missing information. So that's where the magic was happening in that beta integration worksheet. This is also where we were calculating the MEP embodied carbon calculation because it's not currently in the Beam tool. So we developed a sheet specifically for that in that integration sheet. So raters were completing that and then manually integrating the information into the Beam model. Eventually, that whole workflow would be more automated and then reduce the time. But within the time frame that we had for the study, that's what we were able to achieve, and it gave us so much great insight for like future development on like how to speed up that workflow and what we need to do. So that is the basic methodology. So then we had those 13 raters. We trained them on this new workflow. They were completing all of the Beam model and beta worksheet for all of their 100 projects. And then the research team QA'd every single of them to make sure that the data was accurate, provided feedback to the raters to help them like create their model faster. So there was a lot of back and forth between them to help them. So yeah, so that's the study in a nutshell. Now the fun part. Let's look at some of the embodied carbon results. I'm going to pass it to you, Chris.
Okay. Okay, so I guess, the headline from a study that wanted to figure out what the average embodied carbon of a new home in Massachusetts is this one. If you're not used to reading whisker graphs, sorry, this is a little busy, but I'll kind of walk you through it. So, like I said, the report has lots of great detail. One of the interesting things they did was break out results by house types. So the first four sort of grayed out results here. Not that they're not important, but you can see there's results for single detached one story and single detached two story and duplexes and townhouses, all within a reasonably similar range. But if you average all of them out, the average was 55.5 tons of emissions from the A1 to A3 embodied carbon for every house. So that's the little thing, circled in orange in the middle there. You can see that the average results sort of fit in a fairly tight range. It wasn't a huge range, but you can also see that there was a house with as little as 18.5 tons, and some with over 140. So there's a big spread there. But if we're sort of thinking, well, what's a reasonable average to aim for a new home in Massachusetts, somewhere in that sort of like 50 to 55 tons seems to be, over the 100 homes we looked at, a pretty reasonable kind of mid-range target.
And for those of you who doesn't know what 55.5 tons look like, Chris, do you want to tell us?
Um,
It,
no, because I can't see the notes, so you can
okay,
tell
I
me.
can tell you. Yeah. So 55.5 ton is over 140,000 miles driven by a typical car, right? So we need to look at those numbers.
So the second version, it's the same sort of headline figure, but also of interest is not just how like the total emissions per home, because obviously, a big home is going to have likely more emissions than a much smaller home just by the amount of material. So another really useful headline figure is the embodied carbon intensity. So that's where we take the number from the previous slide and divide it by the conditioned living area of the building. So now we're looking at kilograms of carbon dioxide per square meter of conditioned floor area. And so it's the same homes, but this is actually, if you want to compare one home to another home, this is actually a better metric because you've sort of taken just the gross size of the building out of the equation a bit more. And so here again, we see some variation between the different types of homes, but the average across the 100 homes was 226.8 kilograms of emissions per square meter of floor area. And again, you can see there were some real outliers in terms of the low end and the high end, but also a pretty good tight cluster. And so again, if Massachusetts is interested in looking at embodied carbon through the lens of intensity, somewhere in the sort of 200 to 250 kilogram per square meter range would be a pretty typical target to be using as a baseline or a benchmark. And then we wanted to see how this compared to some of the other studies that Builders for Climate Action has done. So Builders for Climate Action has done studies for the cities of Vancouver, Toronto, and Nelson, British Columbia. And you can sort of see the Massachusetts, these are the intensity results, are in orange. We've changed the number here because we took the MEP part out of the Massachusetts results. So that's why this number doesn't look the same as the one we just showed you, because this is the first study of homes to ever include MEP. So to compare it to the other studies, we sort of eliminated MEP. And when we do that, you can see, especially between Massachusetts, Vancouver, and Toronto, like the results are shockingly similar, which sort of says, maybe there's not so much regional difference in these buildings. We do tend to build homes very similarly across North America, and these intensity results sort of bear out the fact that what we have found previously aligns really closely with what we have found here in Massachusetts.
All right, now we're gonna look at those results, but per material categories. So we found that actually MEP is a major contributor. So if we look at the gross material emission by category, we see that actually um, 76% is from only 4 categories. So concrete is always the biggest contributor to embodied carbon emission. So that is a low-hanging fruit to look at. And then we have MEP that wasn't looked before, but we found around 18% of the upfront carbon. And then we have insulation and cladding. And that really matched with what we found in our other studies, but now adding MEP as the fourth biggest contributor. When we look at MEP, we found that the mechanical or HVAC, so the heat, ventilation, and air conditioning system, are the largest contributor to MEP embodied carbon. We see here we have the mechanical results and then electrical and plumbing. And that is interesting because there's probably a lot more option in the mechanical to like choose between different systems than electrical or plumbing. So doing more research to find like what influence this will be one of the next steps to understand how we can and if we can reduce those emissions. Now, if we look at other bigger contributor, concrete is the biggest one. There's a lot of ways to reduce your concrete by using less, but one way is to change your mix. So the study assumes standard mixes for it, but depending on your strength or the supplementary cementitious SMC, yeah, material that you can add in your carbon in your concrete mixes, you can reduce your emission by 36 or 38%. So there are ways to reduce this that are fairly simple. And then if we look at insulation, it was around 11% of the material carbon emission. And that is a really interesting category because there's so many options that you can choose from to actually reduce your emission. And a tool like Beam can really help you make better decision on those material that we reduce overall your emission. And then cladding was another category that also have a lot of option that you can choose from to reduce your emission. So from there, we're going to look at a really interesting part, the embodied plus operational carbon results. To you, Chris.
Yeah, thanks. And this is where this study was interesting for sure for all the other things that we've looked at, but it's particularly interesting because we have these HERS models for all of these homes. We're able to sort of put embodied and operational emissions results together really easily, and so there are some great takeaways from this. Can forward me. So I think that for me, the main takeaway here is that what this study points to is that the level of energy efficiency achieved by a new home is not a predictor of its embodied carbon performance. I think in a lot of in the time that embodied carbon has sort of emerged as an issue, there's been a tendency to kind of frame it as, well, if you're trying to make a building more energy efficient, you're probably going to raise the embodied carbon, particularly from using more insulation or say, triple pane windows. There's this notion that, well, we're actually going to you can't raise the energy efficiency without also raising the embodied carbon, and vice versa. If you're really trying to reduce the embodied carbon, you're likely to reduce the energy efficiency. And what this study pointed out is that there's absolutely no basis for that. So we had homes, the raters grouped the homes into 3 different levels of energy efficiency. So those with a HERS index score of 39 to 48, so that's at the more efficient side, through a sort of mid-category HERS index of 49 to 51, and then a less efficient group of homes that were HERS rated 52 to 60. And what you see above is the embodied carbon intensity of the homes in those ranges, and really there's no discernible embodied carbon difference between those categories. So the averages are very close to each other. The 25th to 75th percentile, sort of the box part of these diagrams, align pretty closely. And so I think that's a great indicator that, this dichotomy does not truly exist. We actually can be able to, you can obviously make more energy efficient homes over here on the left and at least not raise the embodied carbon. You can at least do it by keeping it in the same range. And interestingly, even some of the outliers were similar across these three categories. So to me, this was a really important takeaway that we don't have to think of operational carbon and embodied carbon as an either or kind of predicament. We can, obviously address one without necessarily affecting the other.
Or we can address both.
Exactly. One of the other, interesting takeaways is that so we had the HERS raters had looked at operational emissions over a 25-year window, and this is using the averages across the whole study. So the average embodied emissions were just under 56 tons. The average operational emissions were 118 tons, and what that means is that it takes, on average, in Massachusetts, about 12 years before the operational emissions from new homes have sort of caught up to, or those emissions reach the level that the embodied emissions reach. So, that just sort of, it's a great demonstration of how important it is to address embodied emissions because, for at least the first decade, and it depends, some houses it was as many as like 3 to 4 decades, the emissions profile is dominated by embodied emissions. And as Mélanie pointed out earlier on, all of those emissions go into the atmosphere basically before the building is occupied. That means they're in the atmosphere and like driving warming, consistently from that point forward. And so, seeing that that they make up, over 30% of the 25-year kind of emissions pie just really stresses how important it is to be able to look at this and start reducing these.
Yeah, and 25 years put us like a little bit over 2050, and we need to reduce, according to research, to zero our emission by 2050. So we need to look at those emissions. We cannot just look at operational carbon emission.
Yeah, and so this slide is no surprise. This wasn't a great revelation in this study. That the all electric homes in this study, you can see in the little orange box on the left, by far had the lowest operating emissions. And this is nothing new. We've known for a long time that energy efficiency and cleaner energy going, powering buildings, those are the two ways that you drive down operational emissions. No great revelation or shock there, but confirmation that's the case. And then on the next slide, what's interesting about the embodied carbon results is that none of these 100 homes entered the study with the builder or the designer having thought about embodied carbon intentionally. All of these homes are sort of constructed in the past year or two, so they were already built, and there was no sort of, none of the homes were picked because the builder was trying to address embodied carbon. And so what we get from the study is we see that the highest embodied carbon, but looking at the building on the left there with over 140 tons of embodied carbon emissions, and one of the lowest ones at 27 tons, both of those just reflect some builders' business as usual pathway. Nobody was attempting to make a high embodied carbon home, and nobody was intending to make a low embodied carbon home. But what that means is that we can achieve both of these today. They were both doable, they were both reasonably priced, they were both code compliant, like they both made sense for a builder to make. And I call the one on the right the happy accident. There was obviously a suite of products used on that building, not necessarily to achieve low embodied carbon, but had the end result of achieving low embodied carbon, but not really with any intention. And what we're hoping that this study does is sort of elevate the things that enable a business as usual home to hit that really low embodied carbon rate and sort of avoid the worst case scenario on the left. And just to sort of wrap up this section, I think we really do want to stress that operational emissions and embodied carbon emissions are not an either or kind of strategy. It's a yes and. We need to reduce both. As Mélanie said, eventually we have to get, and in fairly short order, both sides of this equation down to zero. And, we can see from this study that a whole bunch of the main strategies for reducing operational emissions or increasing energy efficiency, reducing the building size or surface area, increasing insulation, moving to high performance windows, etc. Everything on the left, we can see from the results of this study and other work we've done that you can achieve those operational performance improvements and either keep embodied carbon the same or even reduce it at the same time. So we need to sort of break this notion that you sort of either address one or you address the other, but there's no way to address both. I think that's one of the great outcomes of this study is a real confirmation that nope, we actually can, and it's good because we need to be looking at sort of both sources of emissions from our homes.
And even more now that we look and start to look at MEP, like we see that like designing well your building so you have a smaller mechanical equipment and then everything is aligned so you have like less plumbing, less electrical is contributing to overall reducing embodied carbon and your energy efficiency. So like there's so many overlap between the two that it like you're probably doing like those builders that are in those studies that have like really low embodied carbon that didn't even try to do it, but they're already doing it. So you're probably also doing it right now. You just don't know it. So this is to like highlight that. And I just want to add like this is not rocket science. Like people are doing it right now. So there's no reason why we cannot do it. It's just about choosing the right material and having the right design, right? All right, now to the last part, the HERS radar and embodied carbon. So as I mentioned, this was the first time we like trained during a study like radars, and I'm sure some of you are in the crowd today, and I want to have a big shout out to you. You did amazing. So we saw that HERS radar are super well positioned to support embodied carbon assessment with modest additional effort. So on average, the radars reduce their completion time of embodied carbon assessment from 3.5 hours to 2.7 hours. So 23% decrease after completing 5 to 10 projects. And that was within like, I think it was like 3 months of work. So that's really good. And also, as we developed like the tool, like that time would even be reduced by more when the data import to Beam will be like automated. So we already have good results. So we see that there's good potential there. What we learned while training those raters is that there's some gaps in their understanding. So like 55% identified that like it was hard for them to identify specific products or like materials from the drawings, like the one that they're not used to identify, or like have like standardized guidance on the level of detail needed to do their takeoff. And then like 20%-ish struggle on identifying and assess like structural elements. So everything that was not part of their usual work was a little bit harder. And I mean, yes, of course. So when we questioned them after the study to understand better, they recommended training in reading plans and material takeoff, which we also realized during the study. We created more educational material as like videos and stuff, having a better general construction knowledge. So everything like that is mostly underground, if I can say. So like footings, like rebar, that was the hardest part, I think, for them, that like we need to educate a little bit more. And then also more like embodied carbon fundamentals. I think it like sparked their interest for embodied carbon fundamental. The training was really specific on like the workflow. So we didn't really cover like how to reduce embodied carbon because it like then we would have run like a week of training. But yeah, like they want to know, like, okay, now that I know that, how can I help my client to reduce their embodied carbon? So some delivery format that they like was visual and then video guides, which we provided a lot. We did some webinar and then email updates and like peer collaboration. There was like someone on call for them to meet to like help them do. So that's our learning. So to wrap up this study, what we found is that study demonstrate that embodied carbon analysis can be combined with typical operational energy assessment, and the study illustrate that scalable and practical pathways to more holistic carbon accounting in residential construction is possible. So we now have everything that we need for like market transformation. We have a standard that can ensure like fair and inclusive implementation that will be published. We also have innovation through like new tool development to integrate like a better workflow and be more efficient. And we also have workforce development started through that study to test the workflow. And the great thing with that study is like, yes, it provides region specific data and support workforce development, but can be replicable quite easily for like other region in the States. They can do the same thing and also help their market transformation through that city. And then I think, Chris, you also wanted to add on that piece. I think you're already looking at developing more training for raters.
Yeah. So under the workforce development, as the ResNet 1550 standard gets published this spring, we're also already underway in developing a pilot training program. So more information coming on that soon. But I really like the framing here that this study sort of shows all of these things are in their early days. The standard is just about to come out. A new version of Beam that integrates with Ekotrope is about to come out, and this pilot program, training program for 1550 is about to come out. So this study really showed the value of having this suite of things available, and I'm really excited, to see it really pick up speed once all three of these things are kind of out in the market.
Yeah, and we could have also add like this kind of study help also to for like policy or like programming incentive to really help like that market transformation, because now we have data um, that can be used. Right. And then here at the resources, I don't know, Chris, if you want to speak to them, you have your little QR code.
Yeah, I was just gonna say the QR code will take you to the PDF for the 100 home study. So I would encourage you to go there. There is both a lot more and a lot more depth than what we are able to cover in this short webinar. And the other resources there, the top three are different studies that Builders for Climate Action have done that are similar. And the bottom two is some of my work with RMI on embodied carbon emissions in the home building space too. So with that, we can turn it over to some questions.
Yeah, thank you so much, Chris and Melanie. That was awesome. Great stuff there. Just want to say that we are going to prioritize questions from the audience, not in the chat. Those who raise their hands come off mute, and then, please, for the sake of time, keep your question brief so we can get to as many as possible. There's a lot of great stuff in the study. But Scott, you've had your question up, or your hand up for a while. You got a question? Scott, you there?
Why don't you move on to Helena?
All right, I'll move on to Helena. Helena, you're muted.
Sorry. When you calculated the average of embodied carbon, the range was very large. What is the relationship between the house size in each category of houses and its embodied carbon? And let's say in the range between 2 and 5,000 square feet homes. it's not linear in operational energy. So I wonder what it is here.
Yeah, I would say it's not linear here either. And I think, that you will see more variation in the results if you're just looking at the total embodied carbon from home size. If you use the exact same suite of materials and made a home twice as big, there actually would be a fairly linear relationship, but that's rarely ever the case. If we want to compare between homes of different sizes, the intensity is a better metric because we're sort of normalizing the amount of embodied carbon to the area. So, but again, like you pointed out, we do see a big range, and we see a big range because the products that go into a home have a big range. You can use, I'll pick on roofing, but you can roof a home with a product that has 3 times the embodied carbon of another product. And so, when I was talking before about happy accidents and sad accidents, it really is the often the suite of products that somebody has chosen for the building.
Okay.
You've chosen a lot of really high emitting products, or you've chosen a lot of really low ones, but in both cases, specifically for the intensity, though, it is those product choices that make the difference. And
Got
so that's kind of at the heart of it.
Thank you.
Yeah, Scott, do you still have a question, or is your hands
Yeah, it's still up.
okay?
I unplugged my speaker. So you had the slide that had the highest intensity input and energy usage in the slide with the lowest intensity embodied carbon and usage. And my question is, did you take out of this thing those houses that were trying to get FIAS certified? Not all of them get certified, or a lot of them have to get HERS rated to get building occupancy because the FIAS certification comes a year later. Because FIAS has both an embodied carbon and an operational part of being certified. So, and those builders are inclined to do this, and I think that might be skewing your recommendations, because I know in Massachusetts, most people insulate with one of the spray foams, no matter what, whether they're doing retrofits or anything else. And obviously, that's something you want to eliminate because that's one of your highest embodied carbon products.
Mel, you were more like in the weeds of each of the homes. I don't know if we know how many were FIAS certified or not.
We don't know how many were FIAS certified. Like we really went to like represent what was built in Massachusetts. So the 100 homes we wanted in terms of like sizing, types, and then also like her score. So that's how we like choose our sample, not so much about FIAS. So I would have to like go back in it and check if we on that, but that the goal was to represent what has, and there has built homes, right? So that is like the last I think the cutoff was like 2020, if I remember correctly, and Andy is on the line if he wants to speak to it, but yeah, we don't know about FIAS. Oh, and Dee just said that like he doesn't believe any homes were FIAS certified. There you go.
Definitely have a few more questions. Just quickly, Chris and Melanie, we have about 10 minutes left. Could either of you stay a little bit longer so we can make sure we get through some of these questions?
Yes, I should be able to do that.
Okay, awesome. Then now we can go Cindy, then Paul,
Noor,
Jeff, and then
Noor,
Glenn.
Thank you very much. My question, thank you for doing this research and presenting it. This is really, really exciting stuff. My question is a little bit similar to Scott's, and so none of the, or you think that none of the homes were FIA certified or sort of building to any passive house standard, but is there anything in that same sort of like, the happy accident, the really sort of large embodied carbon and the low embodied carbon, is there anything that you can say about the ones that were really low, to sort of qualify them in any way? Can you say like, oh, well, I mean, and I don't remember if that was just embodied carbon or if that was embodied and operational, but is there anything you can say about those homes, those happy accidents, the ones that happen to be lower embodied carbon, anything in particular, any sort of generalities that you can make about what the lower embodied carbon homes had? And then I had another quick question about, I love how, sort of getting the HERS raters is and sort of identifying what they might need. Did you have any sort of, quality control or quality insurance or like sort of double checking sort of in the process of what results came out? Thank
Sure.
you.
Maybe I'll take the first part, and then Mel, you did the QA, so you can take the second
Yeah.
part. Cindy, I would say, I don't know the particulars of every home in the study, but I would say, again and again, we've done these studies for cities, we've done them for individual builders and developers. The pie we showed of the highest impact product categories, concrete, now we know MEP, insulation and cladding. So typically, we focused on concrete, insulation, and cladding because we didn't have MEP data. And it would be, with embodied carbon, it's always the hierarchy is sort of like use less and then use better versions of the thing that you're using. So, I would hazard to guess that in this study, the buildings with the really low embodied carbon just used less concrete in one way or another. They had shallow foundations. They did not have slabs, or they had thinner slabs. In some way, they used less concrete than a typical home. They used better insulation products. There were a handful of homes in this study that used cellulose, which would sort of be one of the lower embodied carbon options. They used a cladding that was not from the high end. So brick cladding tends to be the highest. You're almost always going to raise your embodied carbon if you use brick. Various types of wood and engineered wood and stuff are at the lower end of that scale. So, I would hazard to guess that the homes that were, showed exceptional results managed to combine all of those options into one, and vice versa for the ones that were high.
Yeah.
I'll let Melanie speak to the QA part because that was definitely part of this.
Yeah, the QA process. So we did develop like a whole QA process, and what we did is after we trained raters, they had to complete the first part of the assessment, so like the beta integration worksheet, and then we were queuing that, giving them feedback, and then they were completing their meme model, and then we were queuing that and then giving them feedback. So they had to do one full model before like going and doing their other like four or more, like each of them did five or more model, and then for every single model we were like 2% queuing everything to make sure it was aligned. We of course we were using energy like model that were certified, like HERS model from Ekotrope. So we did assume that there was already some sort of like QA that went into those models, since they're like certified and stuff. So like we base our assumption that like because we're extracting the basic information from that, like it's good, but the raters we were also like queuing that process of like, can we actually use this data to do embodied carbon? And then how can we make the process better if those inputs are more aligned with what we need for embodied carbon? So there was totally like a fact check, like a QA process through this whole research.
Paul, you got a question?
Yes. Um, First off, this is a great presentation. Thank you so much. I just wanted to sort of raise a little bit of a pointer or question, which is I know that we're focusing on sort of the A1 to A3, the cradle to gate side of things, which reflects a moment in time. Um, but I wondered, Chris, if you could speak to life cycle of some of these products, because over time, there are different building components that will have to be replaced. And um, as we get into that, that may change the way that we look at the embodied carbon because some building materials may have a longer longevity. Um, and I think where we are is where we absolutely have to start from an adoption perspective. But I don't want us to lose sight that life cycle will play a factor, especially as we get into some of these things that we have to replace more.
Yeah, I totally agree. I think there are sort of when we look at the whole life cycle of a building, the product stage emissions, the ones we focused on here, are the ones. There's sort of two reasons we focus here. One is this is where we have really good data. Like, each product has its own EPD, or a group of products will be under the same EPD, but we have really good data representation on that product stage. And also, when you do look at the whole life cycle of a particular product, the product stage, typically really dominates, like, anywhere from 65 to 85% of a product's whole life cycle emissions happen in the product stage. So that's the reason we're focusing here. I 100% agree with you. I think it is really important to think across the whole life cycle. Some of the reasons we don't do that now is we just don't have the data to support good analysis moving forward, and that's especially tricky in the residential sector. In the commercial sector, there are, some at least rules of thumb. I still question how accurate they are, but for, things like transportation and installation and especially use and maintenance, because commercial buildings tend to have plans, right? You open a hospital or you open an apartment building and you're going to change the carpet every X years, and you're going to, there's a plan for how that happens. I think in homes we don't have as good a sense of what the future holds for a particular home. Some of these new homes might have gotten built and the new homeowner might have ripped out half the flooring on day one because they wanted something else. At the same time, somebody might have moved into that home and that flooring is gonna stay there for 100 years. Like, we don't really. There's a lot of speculation we'd have to deal with in terms of really trying to think through the full life cycle. I think life cycle, you're right, becomes really important for products that do need replacing more often. And I think seeing in this study how big an impact MEP is, and knowing that especially HVAC equipment, which was the most impactful of all the MEP products, knowing that those things often change, in what, 15 years, sub 20 years, and they represent 20% of the embodied carbon, that is a big sort of flag for the future. I would say, right now, for myself anyway, I kind of, have we need to think about this and figure it out flag planted in the future life cycle stages. But still, really working to figure out how to do that in a way that, is as true to life as we can make it, and sort of testing a lot of the assumptions that currently exist for looking at future emissions.
Okay, so we are at 10 o'clock now, and I understand that that is how long we're going to go. So, okay, if people want to hop, we are going to stay on for a little bit to sort of wrap up a few more questions. So if people can stay, that's awesome as well, and we appreciate that a lot. Jeff, if you have a question, please jump in.
Hey, thank you. And thank you for a great presentation. I learned a lot here. My question was about the cost. well, maybe I missed a slide there, but the it seems like perhaps the lower embedded cost materials, are they more expensive?
That's not something that was part of the study. We don't know the costs of these buildings, but in other work, we have found that there is, again, no direct correlation between cost and embodied carbon. Sometimes the most expensive product has the highest embodied carbon in a category, and the lowest cost has the lowest, or it could be vice versa. Like it's not a direct correlation. Sometimes, and again, I think the fact that we had a good number of homes in this study, which were kind of production homes, they weren't, anything special or expensive or, out of the ordinary, that did have extremely low embodied carbon, says that those were affordable and accessible solutions. But we don't have actual dollar amounts per house tied to this study. We don't know that, but certainly, if you look at and if you go to some of the other studies that we had on the resources slide, there is a look at cost and embodied carbon, and just like with energy efficiency and embodied carbon, there is no direct relationship. So the lower embodied carbon product does not sometimes cost less and sometimes cost more. It's not there's no um, norm there.
Interesting. Okay. Just a comment, if we had a carbon tax, that would really incentivize people to use the lower carbon materials. Thank you very
Indeed, it
much.
would, and that would be very that would have a lot of common sense that would make all of this easier.
We'll,
Len and
we'll ask
Steve.
we'll ask for a vote from this group in just a moment. Sorry.
No problem, Glenn. Go ahead.
Thank you. Correct me if I'm wrong, but I don't believe that rooftop solar was considered either from an embodied carbon or from an operational perspective, or was it?
It was not from an embodied carbon aspect. Melanie and or Andy would know if it was part of the operational like the HERS rating for any of these homes.
Yeah, I think Andy was covering more the energy. I don't know if he's still on the line. Because like that would have been covered in the HERS model, right? So I think it was took into account in the operational carbon assessment, but I would have to confirm with Andy. It was
Yeah,
not part of the embodied carbon, no.
Yeah, it's an interesting question, Glenn. We in the ResNet 1550 standard, we actually include a calculation methodology for solar, but it's not a required part of the assessment because it gets into a tricky scoping question because if you're going to assign embodied carbon for energy generation to a home just because it puts its energy generation on its own roof, you theoretically should also be assigning homes embodied carbon for the generation that they're using that doesn't happen to be on their building, right? Like it gets into this funny scope case of if we're going to count embodied carbon of energy generation, every home should bear a burden for every power plant and transformer and everything upstream. And so just saying, "Oh, look at solar, it's got embodied carbon." Yes, it does, but so does the thing that you would be using if you didn't have solar. So I think it's good to know the embodied carbon of solar in particular, so you can say, "Hey, are the emissions my solar is offsetting greater or lesser than the solar I'm putting on?" Like as a one home kind of decision, but as a way to look at it, it sort of really blurs our scope boundaries when we start attaching energy generation to a particular home.
Point taken. And just quickly, do you have any sense as to whether there's any significant differences across manufacturers or however one would disaggregate rooftop solar? Is a KW rooftop solar pretty much a KW rooftop solar in terms of the embodied carbon?
No,
Oh.
it has the same issue that all embodied carbon does. Embodied carbon has to do with how a product is manufactured
Yep.
and to a great degree where it's manufactured. So an efficient factory that's using clean energy has a lower embodied carbon. An inefficient factory or one using like high emitting energy
Huh.
sources. So the product that you hold in your hand could literally be identical. Like, if some companies actually do facility by facility EPDs, and so you are literally creating the same product from the same manufacturer in two different places can have
Yep.
radically different embodied carbon. So yes, solar has the same, a huge range in embodied carbon.
Thank you.
You're welcome.
Go for it, Steve.
Okay, very quickly. Great presentation. Although it is get the minds going crazy. I've only been at this for 46 years, so and nice to see Glenn. But at any rate, I guess one question on the report: how much does the report go into detail on the calculation of embodied carbon by type of product? This, furnace versus that furnace, or this installation versus how deep do you go to describe how it was figured out between product A and product B? It just sounds like it feels like a challenge to, run down that line of, how to come up with the embodied carbon
Yeah.
analysis.
We do cover that a little bit there's like appendix like after the main body, so you can look at that. And also like it refers to the methodology that the beam tool used to calculate embodied carbon. So you have a lot of that on the Builders for Climate Action website. But basically, the beam tool use, like we mentioned earlier, environmental product declaration. So that's like a PDF where we can find the GWP number. So that's a global warming potential factor for a specific material or product. So what we did at Builders for Climate Action is we look at a bunch of those EPDs and then build like a database in the back end. So then people enter their like area, and then we have the GWP for example, meter square, and then you enter a meter square. So then the tool calculate like what is the gross emission for that material. So it's just math. It's quite simple. It's like quantities time like that factor, and then we like sum all of them. But if you want to dive deeper, you may find more. You're gonna find a little bit in this study, but then since it's really well covered on the Builders for Climate Action website and some of our earlier studies, we didn't repeat all the information in that one since it's already pretty long. So if you want to go deeper, I would suggest to go see some of our first studies. I don't know, Chris, if you want to add.
Yeah, I would say like it's an interesting point, Steve, because these homes were assessed in retrospect, right? So
Mhm.
to some degree, the rater had information on the exact product being used, and in some cases they just had a product type. And so, say you're using fiberglass batt insulation, if you knew that you were using brand A, the beam tool has the option to pick brand A. If we didn't actually know that information, you used the beam tool also then gives an average of EPDs in a product category. So the results are actually a mix of we actually knew the product and we specifically picked the one that was used, or we knew the product type and we picked an average. So there is a bit of variation there between the level of accuracy. Also, not every product has an EPD, so sometimes you might know the exact product that manufacturer doesn't have an EPD, so we still default to that average value in that category. So, there's a bit of blending there that is inevitable just because of the data transparency
Yeah.
and the amount that we knew or that the raters knew about these homes in terms of their, exact product selection. I think concrete's a good example, right? We had no idea what concrete mixes were used in any of these buildings. So across the study, we defaulted to the standard mix in Massachusetts. Some of them might have gone for a really low embodied carbon concrete. We didn't know that. We didn't want to assume that. So, there definitely are some, discrepancies built into the study based on the depth of knowledge we had about products.
Yeah, and 2 points I can add to this. The 1550 covers that, like which EPD to choose depending on like what information you have. There's like some instruction in the 1550 for that. And also like Chris mentioned, if we were to really apply this workflow to Rader's job right now, it would be slightly different because they would start from the beginning doing their energy model and also like going on site and having potentially like a closer access to the builder to or like the GC to validate those missing information about like material or like product specificity. So like the context of the study created this like specific workflow that we tested, but like if we were to apply in a real case like situation, it would be slightly different where we would start at the beginning when we create the energy model, we would simultaneously create the embodied carbon and then have better information and simpler workflow as well. I see ND, sorry. I don't know if you
great.
want
Thank
to
you
add
very much.
something. You're
Great
welcome.
work.
Hey guys, I wanted to just add to that point. The MEP piece, as Chris mentioned at the beginning of the presentation, this is the first time that a study included MEP, and the reason it was possible is because Jacob Rakusin was charged by ResNet to kind of traipse the globe and find out what some averages were for MEP that we didn't have before. So while we were evolving the study, some real data was coming back from Jacob's efforts, and that's how we were able to align the MEP piece with this study. So I just wanted to clarify that. That's like it's evolving. I see that you're from NEEP, Steve. So I wanted to make sure that you knew that we're paying attention to equipment. But this is kind of burgeoning and just getting out of the gate. So MEP will be continued to be studied by ResNet and in 1550.
Yeah,
So
yeah.
good
And
to
just
see
to
everybody.
clarify, MEP is one of those categories where you cannot choose a specific product right now. Like there is no heat pump A versus heat pump B. There is a generic factor for a heat pump based on its output. There's a generic factor for a furnace. There's a generic factor for an electric hot water tank. So because we don't have EPD level data for any of those product types right now.
Yeah, thank you all for staying longer. This has been a great discussion. Alyssa, do you have a question?
Yes, thank you. I was just wondering why 25 years for the operation was used as a timeline when buildings are in use for so much longer. And I also saw a bit of chatter in the chat about coordination and advocacy to get building codes changed. And I see some participants have answered with information about Healy's changes to procurement and credits to incentivize this. But I'm just wondering if there's coordination between your group and any legislative or building code state regulation work.
What was the first question? Sorry, I forgot.
Did you ask me to repeat the first question?
Yeah.
Oh, sorry. It was about why 25
Oh,
years
yeah.
was the operation. Was that just to compare it to the Canadian city studies? Because buildings are occupied and have operational and energy costs for so much longer than that.
Yeah.
I'm just wondering if the results would be even more striking and compelling if you used 50 years or 75 years.
Yeah, I think in some ways the 25 is a bit arbitrary, but there were a few rationales for it. Earlier we took the question about like, what about replacement of materials and end of life emissions and stuff? Most of what we are including in this study is going to last for 25 years on the embodied side. The MEP stuff, may need replacing sooner, but we wanted to choose a window where, in broadly speaking, what we were saying was going to remain the embodied carbon of the building. If we extend it to 50 years or 100 years, we then have to really start speculating on how many products are getting changed, what are they getting changed to? Like, we couldn't just use our current embodied carbon methodology to project out beyond 25 years. Also, the operational emissions right now take into account what sort of some anticipated grid changes are. So, using the ResNet carbon index factors, and again, predicting what's going to happen to the energy efficiency of a building out beyond 25 years as mechanical equipment changes, as grids clean up, as new technology evolves, is also a bit fraught. So it's not like 25 years is a perfect number, but it's a number that we thought, like, this is the sort of window of like the things we can do now and know, can bracket that the efforts we make on both energy efficiency and embodied carbon today will be valid, for about 25 years. And then, changes start to happen that get hard to predict. So I don't know if that's a great answer, but it's sort of the best answer we can give, because trying to speculate out 50 or 100 years gets pretty fraught. Like, we start having to put a lot of qualifiers around the numbers, whereas we feel pretty confident in sort of what we're saying now over that kind of time frame.
Yeah, and also match the reduction targets that we need to achieve
by 2050, which
by
is
2050.
25 years from now.
So if we need to reduce emission, it's good to look for a meaningful time frame. Hopefully, we're still going to be there 100 years, but
Okay, well, I am going to have to depart shortly, so but I just want to, I see your head, Fred, but I just want to thank everybody for these questions and for showing up, and really to the whole team. We didn't really give a hats off to Bev Craig at Mass CEC or any of the other funders. Thank you so much for putting resources into this study, and to all the raters and their companies that helped, and everybody involved. This was a really great effort.
So I just want to say thank you so much to Jack for putting this program together, and Chris and Melanie for your presentation, and Andy for your participation in the study itself, and everybody else who participated in the study. And I just have a slightly philosophical point to pick up on what Melanie just said. I would hope that this kind of work, as Melanie said, it happens to focus on 2050. I would hope that this kind of work will tend to draw in and increase the optimism or decrease the pessimism for especially folks coming into the field, younger, next generation, etc. This field needs hope, and you are helping to build it. And I say that to the presenters, to the researchers, but also to all you activists who show up for these programs. Thank you very much.
Yeah.
Yeah, thank you, Fred. Thank you, Chris. Thank you, Melanie. Thank you, everyone, for showing up and coming out this morning.
Yeah. Thanks, Ella. Bye.
Take care.